Okay, so this is Quideo number 4 for AP Stats. So we're going to start with the basic question. And so the question asks about a poll taken about U.S. adults that have either attended synagogue or church in the past week. And so part A asks if p hat is the proportion of the sample who did attend church or synagogue, what is the mean of the sampling distribution of p hat and what is the standard deviation? So we're going to come over here. And so for part A, I just have written that the x bar equals probability 0.4 because it says suppose that 40% of the adult population did attend. So we're going to put that right there for P, and then from there we can use it and plug it in to find the standard deviation. And so we have the PQ over N to find standard deviation, so it's 0.4 times 0.6, and then that gives it over 1785, and you'll take the square root to get 0.0116. So this says that the sample mean of this distribution is 0.4 and the standard deviation is 0.0116. So 40% of the population did attend church or synagogue. Okay, then we have part B, and so part B says, explain why you can use the formula for standard deviation of p hat in this setting using rule of thumb 1. So right here I just wrote down rule of thumb 1, and so it says use the formula for p hat standard deviation only when the population size is at least 10 times the sample size. So our sample was the 1,785 adults that responded, but the population was all adults, whether it be in the U.S. or in the world. It doesn't specify. But either way, we can, based on what we know that there are a lot more than just 17,850 adults in the world. So this does fit, and we can use the standard deviation formula. And then part C is another rule of thumb question, and so it says check that you can use the normal approximation for the distribution using rule of thumb 2. So we'll go back over here and right here. Okay, so for rule of thumb 2, it says the distribution is normal if NP and NQ are both greater than 10. So I just brought this down and did NP, which was 0.4 times 1785, and got 714, and NQ, which was just using the complement of the P value and then the same sample size, and I got 1,071, and so both of those values are greater than 10, so that rule of thumb also fits. And then lastly, for the basic question, it asks to find the probability that p hat is a value between 0.37 and 0.43. And then it asks about if there will be an answer between 3% on either positive or the negative side of the true population proportion. So we'll come back over here, and I'll zoom out a little bit so you can see. And so I just wrote down the inequality that it asked for there to make it a little better to understand. And then, so we went ahead and we had to find the z-score for each of them, and so I plugged that in and got 2.586 and negative 2.586. And so you go in and you find the z-scores, and so I got 0.49% and then 99.51%. And so it's going to tell us that about 99% of all of the samples, or all samples, should be within 3% above or below the population proportion, and that's because of this number, the 99.51%. Yeah. All right, now moving on to the advanced question. So it gives us this very scary looking graph or table of data, and it's about weight loss on tires. And so part A says construct and interpret a 95% confidence interval for the mean difference in estimates from these two methods in the population of tires. So we can go ahead and go up here to where I have the work. And so I have the confidence interval formula written out. So it's x bar plus or minus t star times standard deviation over the square root of n. And so I plugged in some of the values that we have that are given. And so we have the 4.556 for the x bar, and then t star was found in the table for the 95% confidence interval. And so that's going to be the constant variable that matches up with that percentage. And then we come down here and we plug in the sample size and the standard deviation. And then we come over here to where I solved it. And so my answer, the range for the confidence interval is going to be 2.837 to 6.275. And so from this, we can say that we are 95% confident that the true mean of tire weight loss will fall between 2.837 and 6.275. And then and then part B says, does your interval in part A give convincing evidence of a difference in the two methods of estimating tire wear and justify your answer? So we'll come back over here. I don't really have a lot of math written, but I have a nice description. So it says we're 95% confident that the difference in values will fall between 2.837 and 6.275. Because this number is greater than 0, there is convincing evidence of the two different methods and how they estimate tire wear. So yeah. And lastly, the AP question. So this is a long wordy one about a maximum distance that golf balls are able to travel, following like a certain model and stuff, and the standards in their weights and all that really fun stuff. So we'll go ahead and take a look. So it says part A, if the manufacturer sets the mean distance traveled to be equal to 288 yards, what is the probability that a ball is randomly selected for testing will travel too far? So we come up here and we have the simple z-score formula. And so I plugged in the values given of the 288 and the 2.912, and we got a z-score of 1.14, and then the probability of that is 0.8729. And so because that's measuring the left side of the distribution curve. So if you remember, when you're looking at a distribution curve, it only a z-score accounts for what's to the left of the line. And so we're looking for what's to the right in this case, because that is going to be the maximum distance. And so we want to see what happens when it travels too far. So we're going to do 1 minus 0.8729, and we get 12.71%. So there's a 12.71% chance that a golf ball will go too far. And then for B, it says assume the mean distance traveled is 288 yards and that 5 balls are independently tested. What is the probability that at least one of the 5 balls will exceed the maximum distance of 291.2 yards? All right. And so it's going to be 1 minus the probability of all 5 trials being less than or equal to that maximum distance of 291.2. So right here I have 1 minus the probability of it hitting the distance. So like we had up here before, this 0.8729 is going to come back into play because this question, or this little part of the equation, the 1 minus 0.1271 is going to equal 0.8729. And so, but when you take it to the 5th power, it becomes 0.50678. And so then we subtract that from 1 and get 0.4932. And so from this, we can say that the probability of at least 1 ball out of the 5 surpassing the distance is 49.32%. And finally, C of the AP question says, if the manufacturer wants to be 99% certain that a randomly selected ball will not exceed the maximum distance of 291.2 yards, what is the largest mean that can be used in the manufacturing process? So then we'll come back down here, and there's my part C. Okay, so if we want to be 99% certain, we're going to need to look up the z-score that goes along with the 99%. And so that number is going to be 2.33, found in table A. And so we're just going to plug it into the basic z-score formula and work backwards. And so we get rid of this, multiplied it to both sides, and then subtracted the 291.2. And we got 284.68 for our x bar value. And so this also is mean for the data collected. So from this, since we did the 99%, and we used the maximum, this is the maximum distance traveled, so we can conclude that the largest mean that can be used to reach this, this value, or with a 99% chance of not surpassing it, is going to be 284.63. And so this will kind of give the manufacturer a little more peace of mind that his golf balls will not travel more than 291.2 yards. So that's all I've got.